Hi, welcome back. This is day 6. Day 6 is broken up into two sessions. Day 6a, we're going to be talking about the basic rules of differentiation. And in 6b, discuss some further rules regarding the chain rule, product rule, and quotient rule. All right, so get started. Before we head into the material for today, I just thought I'd point out, I'm sure you already know this, the link to the AP College Board site. I've got a link over here, and if I click on this, this website is everything you need to know regarding the exam, including the dates. So for this year, it happens to be May the 13th of 2024. It varies from one year to the next, yeah, so peruse this site and some information here about the nature of the questions, that there's 45 multiple choice questions, 6 free response questions, and that each of them makes up 50% of the score. Later on in this course, towards the end, I'll actually be going and bringing up some actual exams from the past and go through some of the questions. All right, so let's close this. All right, so the first thing we want to do is talk about the power rule. You actually saw in the previous session when we did x cubed that the derivative was 3x squared, and you found that the derivative written here in Newton's notation was just nx to the n minus 1. That was really just done by, that hypothesis was just done by observation. We need to actually be able to prove this. So we're going to take a look at how to prove this. Before we go, I'll get on with this. I'm going to just remind you about Pascal's triangle that looks like this. I trust you know how this is created. This one's 1, 4, 6, 4, 1, and so on. And I just want to point out that this particular set of entries, which is the second, refers to the second coefficient in the expansion of a binomial. So in the case of x squared, the second coefficient is 2, because a plus b squared is a squared plus 2ab plus b squared. In the case of a plus b to the fourth, it would be a to the fourth, and then 4 is the next coefficient. In other words, the coefficient matches the degree. So this one here corresponds to n equal to 1, this is n equal to 2, and so on, and this one corresponds to n equal to 4. Okay, keeping that in mind as we go through. So the slope of the tangent, we said, would just be the limit as h goes to 0 of f of x plus h. So in this case, it would be x plus h to the n minus f of x, which is x to the n, all over h. When we expand x plus h to the n, the first term is going to be x to the n. And then the next term, as I just pointed out in Pascal's triangle, the next coefficient is whatever the n is. So n, and then the x will be reduced by 1, the exponent is reduced by 1, and the h is increased by 1. So that would be h to the 1, plus, and so on and so forth. Now, all the other terms will all have h's in them, all the way down to the very end, where we'll have h to the n, and then we've got that minus x to the n at the end. And this is all over h. So this becomes the limit as h goes to 0 of, and all the x to the n term, as you can see, as you'll recall from before, goes away. And all the other terms will have h's in them, including this first one. So if I factor out that h, we end up with nx to the n minus 1 plus whatever the next coefficient is, x to the n minus 2, h, and so on, all the way down to h to the n minus 1. And this is all over h. And now the h's cancel. And then finally, we have, as h goes to 0, all the terms will go to 0 except for that first one, because it doesn't involve h. So this goes to 0. They'll all go to 0 because they all have h's in them. And so we end up with n times x to the n minus 1. Okay, so f prime of x, using Newton notation, is just nx to the n minus 1. So there's the proof of the derivative of a power function. Now, regarding the other rules, next one is the constant function rule. So if f of x is equal to some constant, well, then the derivative would be 0. But if you think about this, it kind of makes sense, because if a function is just some constant like 6, for example, that corresponds to a line going through the y-intercept of 6, and so its slope is 0. So f prime, if f of x, for example, f of x is equal to 6, well, then f prime would be 0. Okay, so that's just demonstrating this constant function rule. Next one. If a function is a constant times some other function, then the derivative is just the constant times the derivative of that function. So for example, if f of x is equal to 3x squared, well, then f prime would be 3 times the derivative of x squared. And we saw the derivative of x squared is just 2x. And so we end up getting 6x in this example. So when you're doing this, and you're doing the constant times some power function, the exponent comes down, gets multiplied by that coefficient, so it becomes 6, and then you reduce the exponent by 1. So it becomes 6x. Next one, the sum and difference rule. If a function is the sum or difference of two functions, then the derivative is the sum and difference of the individual. These should have been primed here. So for example, f of x is equal to 7x cubed minus 2x to the 5th. Well, then f prime would be the derivative of the first function here. So remember, using the previous constant and the power rule, this 3 comes down, so 3 times 7 is 21, and you reduce the exponent of x by 1, so it becomes 21x squared, minus, and this one would be 5 times 2, which is 10x, and reduce the 5 by 1, so 4. And so there's the sum and demonstration of the sum and difference rule. Now, let's put this all together and do several examples. Later on, we're going to be looking at a rule that addresses this particular question, but to do this for now, we're just going to take a look at what does 2x plus 3 squared mean? Well, it means, if you expanded it, it gets 4x squared plus 12x plus 9. And then we can use the sum and difference rule that we just saw on the previous screen. And so f prime would just be 8x plus 12. Right? Remember the derivative of 9 would just be 0 since it's a constant. In the case of question B here, f of x would be equal to, before we go taking its derivative, we're going to simplify this. Since both those terms are divisible by x cubed, I could write this as 3x minus 4 over x. 4 over x. And so that's just 3x minus 4x to the minus 1. And so the derivative would just be the derivative of 3x, which is 3, and the derivative of the second term. Again, the negative 1 comes down, gets multiplied by the negative 4, so that's plus 4x, and reduce the exponent of x by 1, so that becomes negative 2. And so we end up with 3 plus 4 over x squared. All right, so the bottom line here is always simplify. If possible, sometimes you can't, and then we'll have to talk about other rules to address that, but always simplify f of x first, prior to finding f prime. All right, so always simplify the function first, as you saw in both these examples, and then take the derivative. So now let's do a question involving differentiation. It says, determine the points where the tangents are horizontal. Well, I can see, having graphed this thing in Desmos, that we have one about here somewhere. There's a tangent there that's horizontal, and there's one down here. It's a matter of determining what are the x values. In other words, what is this and what is this? Okay, that corresponds to the x value for this one and the x value for that one. All right, so the first thing we're going to do is to take the derivative, or differentiate that expression. And so this becomes 3 times that, so negative 9x squared minus 8x plus 6. And remember that the derivative just represents the slope of the tangent anywhere. And so we're looking specifically for where's the tangent horizontal, i.e. the slope is 0. So the next step would be to set f prime equal to 0. So I get negative 9x squared minus 8x plus 6 and set it to 0. Given this is a quadratic, we're going to end up getting 2 solutions, and that'll correspond to the 2 x values producing those horizontal tangents. So using the quadratic formula, x is equal to minus b plus or minus square root b squared minus 4 times a times c all over 2a, which would be negative 18. And that ends up being 8 plus or minus the square root of 280 divided by negative 18. And if you work this out, you get to 2 decimal places anyway, a negative 1.37 and 0.49. Seems to make sense according to the scale of that Desmos graph there. And so now we just need to figure out what is f of negative 1.37 and f of 0.49. Well, if you work this out, this one ends up being negative 9.01, and this one ends up being 0.63. And so the horizontal tangents, to answer the question, horizontal tangents occur at negative 1.37 and negative 9.01 and 0.49 and 0.63. And if you look at the graph up there, it seems to correspond to that. Okay. So this concludes our session on 6A, and we move on, and we'll be introducing 6B shortly. Hope you enjoyed that session. We'll see you later.